Hey guys, Henry from Fishers High School here again. In the previous video, I talked about how I'd be making this math series. Guess what? I still am. And in this video, we will be covering basic theory of numbers. Now, what do I mean when I say that? Well, to understand what numbers themselves are, you really need to understand where they're coming from. And that brings us to an important difference between quantitative and qualitative. Now these are ways of describing something. Is the easiest, simplest way I can put it. So if we're going to describe my shirt, we can say that it's brown. That is qualitative. If we say I have one shirt on, and that is true, then that is quantitative, one shirt. If we say that I am wearing a long sleeve shirt, that is qualitative. If we say that the length of this sleeve is 2 feet, that's probably not true, by the way. Then we go ahead and say 2 feet sleeve. Okay? So, I've given some examples now, but it is really important to get what the actual difference is. So if I say something is brown, and you might have one idea in your head, but I might have another, where you have light brown, dark brown, tan, sandy color, and all those don't really look the same. But they are still brown. So that if I say brown, you might think tan, and I'll think dark brown. But how are you able to distinguish? And even if I were to say dark brown, there's still shades of brown. And when I say dark brown, you might have a different idea still. And that is how it works with long sleeve too. But now let's look at quantitative, how that works. So if I say that I have one shirt on, then you're going to have an idea of me having one shirt on. Now the shirt may look different than what I was thinking, but how the shirt looks is actually qualitative. That's not the primary interest of quantitative. We care that I have one shirt on. There's not any miscommunication as to how many shirts I'm wearing. The other thing that's important to make note of for quantitative and qualitative is this idea of measuring things. That measuring falls under quantitative, so that you can get out a ruler and see how long something is. That's going to be quantitative if you're actually using the numbers associated with that. But if you're just describing something as long or short, then that's going to be qualitative. So, as you've probably figured out, things on the side of numbers fall under quantitative. So that's how you should be thinking of them. So, you're probably used to counting on your fingers right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But in mathematics, we don't really count on our fingers so much as represent it using symbols. So we can represent what we've counted on our fingers with 1, 2, 3, 4, 5, 6, 7, 8, and 9. Where's 10? Well, we'll get to that. So you can see we have unique symbols for these numbers we have on our fingers. And they make pretty much sense, other than they might look strange or not to you, depending on how much experience you've had with them. But they just represent a quantity, each. Now, the next number that we're going to consider is the absence of something. If you're holding up no fingers, or you have no apples, or you have 0 apples. So the way we write 0 in here is just like that. That's a 0. So we can actually go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So why didn't I write out 10 earlier? Well, I'll show you the way we write out 10. But it might be scary, I don't know. That is 10. And yes, it does look like a 0 and a 1 next to each other, because that's what it is. I'm sorry to tell you. So, these are balls, alright? Bouncy balls. We've got 9 bouncy balls. That's fine, right? You can count 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can represent that with a number. But we only have so many unique symbols we can use to represent numbers. Because if you have too many symbols, then the issue is going to be that you can't remember which one is which. And it's going to be difficult to be able to write something that looks the same each and every time. So how can you write the number 10 only using these? Well, we start with our lowest positive number then, 1, because that is actually representing a group now. Because if you have 10 of something, then that means you have 1 of a group of it. And outside this group, because this is only made up of 10, how many do you have outside that? You have no balls outside the group. So you have 1 filled group and none outside that. That's how you get the number 10. And this question mark here means that if you can have a variable number 1 to 9 outside this. So this means a 0 can be 1 to 9, or 0 to 9. 0 to 9. But when you hit that magic threshold of 10, now that means you have a second group at this point. Because a group is exactly 10. Which means here you have 2 groups and 0 outside that. And now, let's say these balls are already groups. So that there are 10 balls in each of these. Okay? And that means, so that's fine, we have groups, right? And we had 9 individual balls here, and then we get that 10th, which means now we have 10 groups. But you remember that we don't have a unique symbol for 10. So what we can do then is call this a big group then at this point, because it's made of 10 regular groups. Which means we have 1 big group, 0 of the normal group beyond that, and 0 individuals beyond that. And that's actually the number 100. And here's the thing, you can do that as many times as you need or want, so that you can keep adding zeros to make a bigger and bigger number. I don't know that I have much more to say about that at this time, other than now you should be able to write numbers between 0 and as many zeros as you want to please. Thank you for your time, guys. In the next video we'll cover just basic operations. Please like, comment, subscribe, and stay tuned.